Welcome, everyone, to The Explainer. Today, we're tackling a subject that is absolutely guaranteed to flip your perspective upside down. We are going to look at how the universe plays these grand, magnificent tricks on our eyes, and how human ingenuity somehow manages to see right through them. To kick things off, I want you to ask yourself a question. What do an invisible wanderer, a ticking time bomb, and a massive 330 million light-year ghost town actually have in common? Now, on the surface, these sound like the setups for three completely different sci-fi horror movies, right? But in reality, they're deeply connected cosmic mysteries that share one profound trait. They are all massive astronomical illusions. They remind us that out there in the cosmos, our initial perspective often completely dictates our reality. Because honestly, space is full of illusions. Throughout this explainer, we're going to explore exactly how the universe tricks us. We'll look at three seemingly terrifying astronomical premises, and we'll see how brilliant scientific discovery and raw data flip those scary scenarios into awe-inspiring realities. Okay, let's dive right into this. Act 1, the wandering black hole. Picture this for a second, an isolated black hole, packing 7 times the mass of our sun, zipping right through the Milky Way, just 5,000 light-years away from Earth. It doesn't have a partner star, it doesn't have a glowing accretion disk giving away its position. It is completely 100% invisible. And when I say wandering, I mean it's moving with serious purpose. This solitary black hole is traveling at a staggering 45 kilometers per second across the galaxy. It's completely alone, just this massive, dark remnant of a dead star hurtling through the Scutum Centaurus and Sagittarius Carina spiral arms. So, how exactly does a massive black hole end up going rogue and traveling alone at speeds like that? Well, it happens through a genuinely fascinating process called a natal kick. When the original massive star reached the very end of its life, its core collapsed. But the resulting supernova explosion wasn't some perfectly neat sphere, it was completely asymmetrical. That lopsided explosion literally acted like a cosmic rocket engine. It compressed those asymmetrical forces and physically kicked the newly formed black hole away from its original birth region, just launching it out into the galaxy to travel solo. Which brings us to a massive, glaring question. If it's completely isolated, with no glowing gas to give it away, how do you see something that eats light? Seriously, how do you track an invisible object moving at 45 kilometers per second? Well, this is exactly where the terrifying premise flips into an incredible scientific triumph. The answer is gravitational microlensing. Think of it as a giant cosmic funhouse mirror. When a massive foreground object, like our wandering black hole, passes perfectly in front of a distant background star, the black hole's intense gravity literally bends the fabric of space itself, and this warps and magnifies the background star's light. An international team of astronomers used the Hubble Space Telescope to watch this one specific background star for about 270 days, and over that time, they saw the starlight gently brighten and fade as the invisible black hole passed by. So this wanderer isn't actually a threat to us, it's a magnificent feat of measurement that proves we really can hunt down the invisible. All right, let's move to Act 2, the Pinwheel Death Star. Enter Wolf-Rayet 104. This is a beautiful, incredibly rare binary star system about 8,400 light-years away, and it is wrapped in a glowing pinwheel of hydrocarbon dust. It's made up of a super-hot Wolf-Rayet star and a massively heavy OB star, and their fierce stellar winds collide to create this stunning spiral. But, don't let the beauty fool you. When we look at that dust pinwheel, we see it perfectly face-on, kind of like looking straight down at a spinning record. And this led to a terrifying assumption in the astronomy world. If the spiral is face-on, are the rotational poles of these stars aiming right at us? Why is that bad? Because Wolf-Rayet stars are highly prone to dying in catastrophic supernova explosions that fire off intense beams of radiation. If WR104 exploded and a gamma-ray burst was aimed straight down the barrel at Earth, well, it could literally be an extinction-level event. And this brilliantly illustrates how just a tiny shift in perspective changes the whole story. New data from the Keck Observatory in Hawaii completely shattered that initial assumption. It turns out the universe was just playing a massive visual trick on us. While the death spiral looks flat and face-on to our telescopes, the actual orbit of the stars is tilted by 30 to 40 degrees out of the plane of the sky. This means the poles of the stars are not aimed at us at all. If a gamma-ray burst goes off, that healthy 30 to 40 degree margin means the deadly radiation will completely miss our solar system. We are entirely safe. Phew, right? I absolutely love this quote from astronomer Grant Hill, who actually led the Keck Observatory study. He says the orbit is tilted at least 30 or 40 degrees out of the plane of the sky. WR104 is not done surprising us yet. It just hits the nail on the head. It highlights a fundamental truth about astronomy. We so often begin with a logical yet terrifying assumption based on a two-dimensional view of the sky, only for the universe to reveal a three-dimensional reality that completely surprises us. Which brings us to Act 3, inside the Booty's void. Now we're looking at a region of space so large it honestly defies human comprehension. The Booty's void is a spherical patch of the universe roughly 330 million light-years in diameter. Just to put that into perspective for a second, our entire Milky Way galaxy is only about 100,000 light-years across. But here is the grand illusion. Despite its gargantuan size, the Booty's void is practically empty. It contains fewer than 60 confirmed galaxies. If you were to take a region of space that exact same size in our cosmic neighborhood, you would expect to find thousands upon thousands of galaxies. In fact, the Booty's void has roughly 1/15,000th the galactic density of our local area. It is a literal astronomical ghost town. To truly wrap our heads around this, we have to put ourselves inside the illusion. Imagine if our solar system and the Milky Way galaxy had randomly formed dead in the center of the Booty's void. Our night sky would still feature the stars of our own galaxy, sure, but beyond that, total, complete darkness. Because the nearest galaxies would be so unimaginably far away, we wouldn't have even known that other galaxies existed until our telescope technology advanced to 1960s levels. We would have spent virtually all of human history believing our lone, single galaxy was the entire universe. So it's the ultimate illusion of isolation. But when we flip that perspective, what looks like a vast, terrifying expanse of nothingness actually serves as a beautiful mirror. Looking at the emptiness of the Booty's void forces us to reframe our own existence. It makes us realize just how incredibly lucky we are to have been placed in a bustling, crowded, dynamic pocket of the cosmos, surrounded by neighboring galaxies that sparked our curiosity and drove our early astronomical discoveries. So what does this all mean? Well, that brings us to our final takeaway, our cosmic luck. The crucial point here is this. We live in a deeply deceptive universe, filled with invisible monsters and apparent death rays, yet we happen to reside in a dynamic, incredibly rich, and surprisingly safe little pocket of the cosmos. The overarching takeaway from all of this is really a testament to human curiosity. By understanding the math of gravitational microlensing, we can track invisible rogue black holes. By measuring precise orbital tilts, we can disarm a cosmic ticking time bomb like WR104. And by mapping cosmic voids, we appreciate the rich galactic tapestry we actually get to call home. Our science, our data, and our relentless desire to understand have proven time and again that we absolutely can pierce the grand illusion space plays on our eyes. I want to leave you with something to really chew on today. We've solved the mystery of the wandering black hole, the tilted pinwheel, and the empty void. But as our telescopes look deeper, wider, and with sharper focus than ever before, what other grand cosmic illusions are we still falling for right now? What terrifying premise is just waiting for a brilliant mind to flip it into a beautiful reality? Thank you so much for joining me on this explainer. Keep looking up and stay curious.